All right, let's get started. Yeah, it's really good to be here. My name is Martijn Walraven. I'm with Apollo, and I've been with Apollo for a very long time. And back in 2018, I was one of the co-creators of what has become Apollo Federation. And in this talk, I'd like to take you through some of the design principles that sort of underlie Apollo Federation, but also the work we're doing together with some other folks in the composite schemas working group. And most of you have probably heard a little bit about this in the keynote yesterday. I want to sort of second what was said there. We've been sort of very happy with the very collaborative atmosphere in that group. And directly after this talk, well, I think there's a 20-minute coffee break in between, but the next talk in this room will be a panel discussion together with the other participants in the working group, or the most active participants in the working group. And as part of that panel discussion, we'd be really great to get some questions from the audience. And because this talk is sort of a setup for that panel in a certain sense, any questions that might come up during this talk, you may also want to add to the Slido, use the QR code, and you can ask a question. We'll go over those questions and incorporate them in the panel discussion. So as part of the composite schemas working group, a number of us got together, sort of, I would say, slightly over a year ago. And our intention was to come to a shared understanding of a standard for federated GraphQL. We at Apollo had been working on Apollo Federation for many years, but over the years, Federation had become increasingly popular, and some other folks in the community had also started thinking about approaches to federated GraphQL. So what we tried to do in that working group, especially in the first couple of months, I would say, is first get to sort of a shared understanding of what we were trying to accomplish. And the first question we asked ourselves was, what do we actually mean by federated GraphQL? Because we had noticed that the term federation was being used sort of increasingly in a number of different ways. And one way of looking at sort of this question is through GraphQL itself. So GraphQL itself is already a technology that is often being used for sort of orchestrated data fetching. It's a way of connecting many different APIs as part of a single schema. This by itself is not federated GraphQL. The next step for many people is to basically ask themselves the question, what if these underlying APIs, instead of speaking REST or gRPC or representing some other data source, what if those APIs also had GraphQL APIs? Wouldn't it be nice, people often said, if we could compose a schema from many underlying GraphQL schemas? And this is actually a path that we ourselves at Apollo also went through. Some of you may remember schema stitching or even used schema stitching. What not too many of you probably know is that that was originally a project, an open source project that was initiated by Apollo. It was later adopted by the Guild, and the most recent versions are, in certain respects, very different from sort of our original naive attempt. But it sort of represents a way of thinking that is still pretty pretty common when people first start thinking about composing schemas. And to zoom in a little bit on this picture, what would an underlying schema in sort of this model look like? So let's say we have a review service. This is some kind of e-commerce site, and one of our APIs represents reviews. So we might have a field representing the rating. We have a body text. But of course, this being a graph, there are also relationships. And then things start getting a little more complicated. And the way we handled this with schema stitching and the way this is still handled in some approaches is to basically say, well, we have sort of a foreign key. We have, in this case, an author ID. We have a product SKU, and these represent relationships. But in this underlying schema, they're just scalars. And that's not all, because often relationships sort of have two sides. In this case, a review is not just associated with an author and a product, but we may also want a way to get the reviews for a product or the reviews written by a certain author. And then in these types of models, you're sort of forced to add query root fields that give you access to these relationships. Something like reviews for user, reviews for product. And this is all very well, but this is not actually a GraphQL schema that you would sort of have a client use. It doesn't really represent a graph. So it's an incomplete schema in that sense. The actual schema you want looks more like this. So we have a review, and a review has an author field that points to a user and a product field that points to a product. And there's a direct way of getting from a product to its reviews. So that's the schema we want, but in these approaches, this is the schema we have. So we're forced to map from one schema to another. And people often look at this as sort of a very flexible approach. They like the idea of being able to basically pick elements from an underlying schema, transform them, sort of shape them in any way they want. But what that leads to is a pretty heavy sort of mapping layer. And there are many ways of actually sort of implementing that mapping layer. You could be writing actual code. You could be using a declarative approach. But in the end, you're still responsible for sort of not just maintaining these sort of two schemas, but also the mapping between them. And this is a very simple example, but even like adding a single field to product, let's say we also want the average rating, that also forces us to add another entry point to the query, average rating for product. And you can see how this sort of quickly leads to a pretty hard to understand schema. The underlying schema is not just incomplete, but it's actually, there are a lot of implicit dependencies here. And the relationship between those scalar fields or those root fields and the types that they refer to, that's all implicit. And there's actually a more fundamental question you might ask yourself here. Why are we doing this? Like, what are we actually gaining from this? Because that API, that review API, it's unlikely that that's sort of an API that you're just now implementing in GraphQL. You likely have an underlying REST API. So you've just sort of added a whole different mapping layer for no clear benefit. You can just as well just implement the schema you want in terms of the API you have. If you then zoom out again, and you look at this picture, the picture that represented sort of people's conception of composite schemas, it's interesting that the questions that actually come up in these scenarios are not really addressed by any of this. And I'm talking about questions like, how do you actually coordinate schema design? Because, as we've seen, we're not just designing isolated schemas. Like a review is not just an isolated type. It refers to products. It refers to users. Those are types that likely also live in other APIs. These are sort of central domain objects that are spread out over many APIs. And from a client perspective, these are the same type. You want to be able to navigate from one to the other. Another question is, how do you keep teams from breaking the API, from breaking the client API? Because if your central layer is a shared resource, that quickly becomes a bottleneck. People might make changes that inadvertently break other people's APIs. So the thing we realized with Apollo Federation coming from schema stitching was that in order to address these questions, there was actually a very different goal that we were looking at. Federation is not just sort of a runtime concern, not just something that talks about like distributed execution, about taking requests from underlying schemas and mapping those to a combined response. It's fundamentally about federating graph development. Like you have a shared goal. You want to work on a great API for your clients. And ideally, it's an API that is sort of product-centric. It really represents the needs of the client and not just the properties of the underlying systems that, at this point in time, sort of happen to underlie those capabilities. So that's where the notion of subgraphs comes in, and composition. And composition is really a very central concept in our approach to federation. The idea is that basically the model I showed you before, where your API sort of exposes types and fields that make sense from a client perspective, that's something every subgraph can now do. This is sort of a modular schema approach. So here we have the types we were discussing before, but this is just one subgraph among many, and other subgraphs would have other types, but also the same type with a different subset of fields. And once we have these subgraphs, we compose them into what we previously referred to as the composed schema. We've started referring to this as a supergraph. And a supergraph in this model is not something you write yourself. It's not some kind of artifact that you write. It's not a mapping file, or it's not code. It's the result of a process of composition. And this process of composition takes in a set of subgraph schemas, and it takes care to ensure that the types and fields that you define in your subgraphs actually fit together. And I'll say more about sort of how that works later, but there's a very sort of principled way of thinking about the process of composition. What's also important is that composition is a build time process. So this happens before you actually deploy a subgraph. And it means that composition is able to detect conflicts, naming conflicts, or dependencies that are not satisfied. And you really want to surface these early before deploying to ensure that you won't break the client API if you make a change to just one of the subgraphs. So in this way, you might say that federation combines sort of team autonomy with centralized governance. As a team, you're responsible for one or more subgraphs, but you have sort of complete freedom in how you actually implement those subgraphs, how you evolve them, as long as you respect the rules of composition, as long as your subgraphs fit in the rest of the graph. And something I want to stress here, because this often comes up in discussions, is that a subgraph defines what you might call an abstraction boundary. It has sort of, as part of federation, it defines its capabilities and its needs in terms of the overall schema, but that's just the outside of the subgraph. There's still an implementation needed for that subgraph. Like something in your system will have to be able to actually answer requests for these types and fields. So a subgraph is actually sort of something that mediates between that product-centric view, that sort of client API view, and whatever underlying services sort of offer those capabilities. And in many cases, that might actually be a REST API, might be a database, there might be computation going on. You can implement a subgraph in code using like the resolver model that we're all familiar with, but that's not a requirement. Like there are many different approaches here. Like subgraphs can have declarative mappings. They can sort of connect to underlying systems in various ways. That can be workflows around sort of how you define these subgraphs and how you define the mapping with the underlying system. So we're not necessarily restricting ourselves. We're not saying, we're not forcing people to sort of buy into a new data model. We're just asking people to be very principled about like how they define these capabilities and how they map them to an underlying system. And one thing I want to stress here is that in this model, subgraph boundaries should never be exposed to clients. Clients should not be aware of where certain data comes from or where certain capabilities live. And there are various reasons for this. Like one is just a simple reason that from a client perspective, like a product-centric API shouldn't have to deal with details of underlying implementations. But another important reason is evolvability. You want to be able to make changes both to individual services, but also to sort of the boundaries between them. You want to be able to move functionality around. Maybe you have an opportunity to use a new API for part of your graph. And all those changes should be possible without affecting the client API. And this also speaks to the fact that the types that you expose in your subgraphs are often shared. It would be a very weird situation where you have like a prefixed product, REST API v1 product, and a REST API v2 product. That leads to a situation where your clients are dependent on those underlying systems. So you really want to be sort of on the lookout for those shared types that make sense from a domain perspective. So that's the big picture. That's what we mean by federation. And it's something that we've long used with Apollo Federation. But within the Composite Schemas Working Group, we've found agreement on these principles. We've made improvements to the model. So we're really happy with the way this has worked out so far. And I want to give you sort of a sneak preview of sort of some of the things we've been working on. But in the context of this talk, I won't be able to go into a lot of detail, and I want to invite all of you to, well, ideally participate in the working group itself, but for now, attend the panel discussion after this talk. But the question you might ask if you're looking for more detail is what would such a principled composition model then look like? And we've already talked about shared types. In Federation, we call those entities. And these entities, they act as sort of hubs in your graph. They're often sort of central domain objects. They're highly connected. Like that's where relationships live. So think about types like product or customer or domain-specific objects like flight or order. And the way we think about these is they're uniquely identifiable through some kind of key. And you may be aware of other approaches to sort of identifying unique objects in GraphQL, like the node interface with its requirement of sort of a single ID scalar field. What we found with Federation is that when you're talking about these distributed systems, there are often very different ideas about sort of what uniquely identifies a certain domain object. Different APIs may have a different way of identifying these objects. These things might change over time. So it was important to us to support multiple fields for an entity and also sort of complex fields. In this case, there's a product that can be identified by either a SKU or a UPC. And different subgraphs may actually expose sort of different keys. And as sort of an evolution of the approach we took with Apollo Federation, the current proposal in the composite schemas working group that Michael already mentioned in his keynote yesterday is lookup. So through a query root field that sort of returns an entity object by ID, you can enter the graph. That's an entry point into the graph. I can get a product by its SKU or by its UPC, and you annotate the field with lookup to sort of signal to the composition system that those are the intended semantics. And there's more to this. There are ways of like mapping underlying fields to different arguments. I won't go into those. But the takeaway here is that these entities are very central in sort of how you think about your schema design. And these keys are how we resolve subqueries between the different subgraphs. But there's more, because there are cases where you actually have other needs, other data needs when you implement a subgraph. There might be information that you don't have sort of locally available in your subgraph, but that you need to perform a certain computation or make a certain call. And this is the example we've been using where in order to compute a delivery estimate for a product, we actually need its weight. And weight in this case is it's defined on another subgraph on the same product entity type. But our delivery estimate field requires that weight. And in the current version of Apollo Federation, we have a requires directive. For reasons that I can't really go into in this talk, we've changed that to a require directive on a field argument that gives us a sort of more standards compliant way of passing in this information. And it makes it easier for people to reason about those dependencies. But the mechanism is really similar. Like both of these expose the capability to request additional data from other subgraphs as part of the implementation of your subgraph. So one way of thinking about the process of composition is that it defines the guardrails for team collaboration. So we have we call this composition validation. There are various stages to it. But basically, what we try to do is ensure that a set of subgraphs fits together. That's the first stage. That means fields need to be compatible. It means that keys need to be properly defined. So the fields you refer to actually need to exist. And all this ensures, when composition succeeds, that at runtime, that supergraph will be able to execute the queries that come its way. So we really want to make sure, and we've sort of defined the validation rules in a way that ensures that any sort of inconsistencies or breaking changes would be detected beforehand. And the way we sort of think about this, define this, is in terms of what we've called the fundamental property of federation. And this is a very informal way of stating it. It's actually, it's a fairly complicated part of the process of composition. But what it basically ensures is that as a client, when you execute a query against the supergraph schema, that query should never error out because we have no way of resolving that query. So we need to make sure that for every possible valid query against the supergraph schema, there should be at least one way of actually satisfying that query by executing queries against the subgraphs. And this may sort of sound like a very reasonable property, but the model, when you start thinking about sort of the subgraph supporting different subsets of keys, different data requirements, abstract types, this model can actually get quite complicated. So this property is really important to ensure that sort of hard to detect cases still lead to validation failures. This is the property that really ensures that there won't be a situation where an otherwise valid query will error out at runtime. So you might ask yourself, what's next for Federated GraphQL, given sort of what you just heard? The standards process in the working group is ongoing. And it's an open process. Everyone is happy to, we're really happy for people to join. Everyone is welcome. We've started thinking of the specification that will be the outcome of this process as GraphQL Federation. That's a working title for now, but we all like it. And one of the reasons we like it is because it really stresses the continuity between what is there today, Apollo Federation and other approaches that sort of refer to federation, and the new GraphQL Federation specification. And there's actually no reason to really think about this as a new specification. We, together with Chili Cream and the Guild, the most active participants in the working group, we've really been able to come to a shared understanding based on not just Apollo Federation, but also new work that they had been engaged in the context of GraphQL Fusion. That's where ideas like lookup and require come from. So we're really happy with the progress we've made, but I want to stress that there are no real breaking changes from Apollo Federation. From our perspective, this is really sort of an evolution from the current version of Apollo Federation, and it's mostly additive. So the new features like lookup and require, you can actually adopt them incrementally, even subgraph by subgraph. There's no reason to really sort of change your whole setup overnight, even if that would be possible, which it really isn't for most people. So this is just to stress that we're really happy with the work that's ongoing, but this will be a process that will take a while. And I think all of us involved in the process are committed to supporting our current systems and giving people a path to adopting these new features. And that brings me again to the panel discussion that will be in the same room after a short coffee break. If you've already done so, or if you have some questions that you want us to discuss in that panel, please use the Slido. I'm not sure if we have time for questions in this room, but it might actually be good to wait for the panel discussion, because I think that's the right setup for most of these questions. Unless there's a question that's specifically about sort of this presentation. All right. Then, yeah, I hope to see most of you in about 20 minutes, and we'll continue from there.